Divya, can you hear me?
Yes, Ravi.
Okay. Before we go ahead, can anybody tell me what is MapReduce? What are its limitations? What is PIC and what are its limitations? Okay, along with what are its limitations and what are the other ecosystem components that we have in order to process the data within HDFS? Can anybody answer this question?
So the MapReduce, the limitations of MapReduce are it can only process structured data, and the limitations of and it's a data processing language, and PIG is a scripting language where you can analyze data basically, and eventually the PIG scripts are converted into MapReduce jobs. And when coming to other MapReduce things, we can use the other ecosystems like HBase or Hive and stuff.
Okay, good. Thank you. Thanks, Shashank. This is what is your total ecosystem here. Okay. This is what is your total ecosystem that we are discussing here. What are the core components that you are having here? The core components what you are having here is HDFS and MapReduce. HDFS is the place where your data is ultimately stored. Okay, HDFS is the place where your data is ultimately stored, and MapReduce is the ultimate place where your data has to be processed. Can anybody tell me the reason? The reason why MapReduce is only the place or else only the platform that is used to process the data in HDFS. That is used to process the data in HDFS. The reason is Google file system, okay, and the Nudge project, when they were created, okay, they have come up with these two components basically. One is the place where we need to store the data, okay, is nothing but a distributed computing system. Guys, hold on for a minute. The place where we need to store the data is nothing but your Hadoop distributed file system, and the algorithms that are basically used to process the data within such a type of distributed framework, the algorithms that are used to process the data within such type of distributed framework is nothing but your MapReduce. So that's why what has to be done is that we may not be in a position. Hold on for a minute, please. Okay. We may not be in a position to use another type of processing platform, okay, in order to process the data that is stored in HDFS. Obviously, the data has to be processed using MapReduce only. But what is this MapReduce? The MapReduce is nothing but a set of all Apache Hadoop libraries, right? They're nothing but a set of all your jar files that has been developed within the Java language only. So that's why what has to be done is, if you want to store your data in HDFS, and if you want to have your data to be processed in the form of your Hadoop, obviously your Java is very much required. JDK is very much required. So this data is stored in the form of files, right? So that is the reason the core shell within your HDFS and MapReduce is nothing but your Java only. Okay, but the other distributions what you're having here, tell me who has invented this particular pig, Shashank? Who has invented this pig? Who has invented this pig, Shashank? Divya. Yahoo, right? Yahoo has invented this pig. Yeah, these things you need to remember, guys. Yahoo has invented this particular pig. The reason is they were facing a problem of analyzing a large number of data sets. Okay, and then they were not in a position to code that many number of large MapReduce programs. That is the reason they have come up with an software, okay, that will allow the user interface, to write the scripting language features. Those scripting language features are there in the form of the pig, basically, and internally you have a pig interpreter that will eventually convert your commands, what you have written in pig, into this MapReduce programs, okay, and those MapReduce programs will be processing the data within your HDFS, right? Will be processing the data within your HDFS. So that is the reason what is being done is that be it be pig or be it be something else also as well, it has to be ultimately nailed down with respect to your MapReduce for the purpose of processing the data within HDFS. So here pig, what type of language is pig, Murli? What type of language is pig? Pig is obviously data flow language, right? Pig is always a data flow language where you can have the option of writing the high level elementary scripts, okay, either in the batch mode or in the interactive mode, so that those pig scripts eventually will be converted into the MapReduce jobs while processing, and it is going to be ultimately processing the data within your HDFS. As I told you, like pig can be executed in two modes. One is in the local mode and second thing is in the HDFS mode. While in the local mode, what happens is you can try to process your pig files with the help of your local file system data. But when you try to execute them within the MapReduce mode, what happens? When you try to execute them in the MapReduce mode, what happens is you have to have the file that is copied into your HDFS on that particular data only. Either the data has to be processed or else the data has to be stored. This is what is pig. And one more question I have asked you guys on the day. Even though if pig is being executed within the local mode, if the pig is executed within the local mode, does your scripts what you are writing within pig will be converted into MapReduce or not? Shashank, my question is clear to you. What my question is?
Yes, they'll be converted into MapReduce.
They will be converted into MapReduce mode. That means that what happens is that irrespective of whether your programs are executed in the local mode or in the MapReduce mode, the pig interpreter is going to eventually convert your pig Latin scripts into the MapReduce programs for the purpose of executing them on this particular MapReduce. This is one thing that we need to really understand. Okay. Now, so pig is basically used for your data analysis. Okay, but I told you right earlier, Hadoop is something that is basically used only by these search engine optimizers for the purpose of solving their big data problems. But eventually, what has been done is that as soon as the number of distributors as soon as the number of distributions got tagged to this particular Hadoop, what has been done is that it also has been converted into the general purpose programming platform, general purpose platform. When I say that it is a general purpose platform, It can use it to process your big data Latin scripts that can be used by your data analysts. It can be used by your application programmers in the form of your MapReduce, as well as there is one section which are not being addressed till now. What is that section? Can anybody tell me? What is the section that has not been addressed till now? What is the section?
Unstructured data.
No, boss. The section that has not been addressed now is the database, guys, right? We have not got the complete attention from the database programmers. Okay, we have not got the complete attention from the database programmers in order to interact with Hadoop, right? In order to interact with Hadoop. See, for the purpose of relaxing from the core Java programming language, the pig has come up. The pig has come. Okay, but with pig also we need to do a lot of scripting. We need to do a lot of scripting. Of course, when compared to MapReduce, it is a way different from your. It is way different from your MapReduce, but still you need to code, right? Okay, and there is a section of database programmers who may not be that much comfortable of coding the things with respect to pig. Okay, they're very much comfortable of using this particular select statements, insert statement, delete, update, and all those particular statements, and especially the data warehousing analysts and the BA analysts would be comfortable of accessing your data using your SQL queries only. Using your SQL queries only. So the place where MapReduce is not able to address the business needs of your BA programmers, okay, the place where your pig Latin script is not that much comfortable with the help in writing those particular pig scripts, that is a place where Hive pitches in. That is a place where Hive pitches in. Okay, so that is the reason Hive is one more component within the Hadoop ecosystem. Okay, that is exclusively meant for your BA programmer, BA analysts. I don't call them as programmers. That is exclusively meant for your BA analysts or the data warehousing guys. Okay, who would like to write the SQL based queries? Who would like to write the SQL based queries? Okay, for the purpose of interacting the data that is present in HDFS, that is a place where Hive is expected to come in. Shashank, is it clear to you?
Yes, sir.
That is a place where Hive comes in. Okay, the query language that can be written in Hive is called as HQL. It is not SQL, it is HQL, which is nothing but the Hive query language. So that is one thing that we need to really understand with respect to Hive. Okay, so let us start looking into these particular things with respect to this Hive. Very, very complicated architecture, but you need to go, but we need to really understand. Okay, so what we can say here, Apache Hive is a data warehousing system built on the top of Hadoop to query big data. So when I want to really query this particular big data, what is required here? I need to have this particular SQL. Okay, the interface that provides this particular programming, the interface that provides this data warehousing context in order to query the data that is present in HDFS is nothing but your Hive. Okay, as Piki has been discovered or invented by Yahoo, this particular Hive has been written by this particular Facebook. Okay, so there are some challenges they say here: data growth in Facebook challenges, the capabilities deployed RDBMS and NoSQL systems. Okay, so reporting and analytics start to take minutes, then hours, and eventually overlap with other queries, and whole system grinds to a halt. The downside which Facebook was encountered is stored in Hadoop is inaccessible to the business users. That is the reason they have come up with this new language, which is nothing but your Hive. So I have told you, like, Hive was developed to access the data stored in Hadoop, translating SQL-like statements. Obviously, what happens is that you may not be in a position to directly process your Hadoop query language statements on the data that is stored in HDFS. But as I have told you, just like Pig is going to translate your your Pig scripts into your MapReduce programs, all your statements which you write in Hive also has to be eventually be translated into this particular MapReduce programs only. Okay, and another thing, Hive queries usually takes some minutes or hours. However, Hive scales well as execute queries across the data in terms of magnitudes of metabytes. See, a question to you guys. When you write a program in MapReduce, and when the same program can be mimicked using Pig script, when the same program can be mimicked using Pig script, okay, can anybody tell me in terms of execution whether MapReduce is going to be faster or Pig is going to be faster?
Pig scripts.
Pig scripts are going to be faster. Pig scripts are going to be faster. Okay, but here a lot of conversion and transformation has to happen for your for your Hive queries to be eventually be converted into your HDFS or MapReduce programs. So obviously, what happens is that there is going to be a lot of data latency that exists. The delay in processing your data in order to get the ultimate result is going to be more with respect to Hive than compared with respect to your Pig and MapReduce. But the thing is that, you know, when the data warehousing specialist would like to analyze your terabytes or petabytes of data, obviously this Hive is something which comes to rescue. Murali, you are following what I'm talking about?
Yeah.
Okay. The next thing is that what Hive is not, as I have told you, that Hive is not a relational database, or else it is not designed for OLTP processing, right? Hive is not really designed for your OLTP processing. In the OLTP processing, we generally insert the records, delete the records, update the records, and when we want to do this online transactions, right? That is basically for your OLTP. So that's why Hive is not for OLTP, and Hive is also not a relational database, and also it doesn't basically create the real-time reporting also as well. Okay, Hive is also not a language for your real-time reporting queries and row-level updates. You cannot update your rows, or else you cannot insert the rows on a row-level basis. Hive queries usually takes minutes to hours. However, Hive scales and can execute queries across the magnitude of petabytes. And Hive does not use sophisticated indexes like many RDBMS systems, which are able to answer your queries within seconds. So that means that based on all these factors, what you are seeing is Hive advantages or disadvantages, guys. Into which factor you are looking at?
If time is the factor, then it is disadvantage. But if data size is a factor, then it's advantage.
As I have told you, Hive is not for the programmers, as well as Hive is not for these scripting people or data analysts. Hive is for the business intelligence analysts, right? The data warehousing people. They really don't bother about the time that is being taken in order to analyze the data, but they would like to cover a massive amount of data that should be queried by your SQL queries or Hive queries. That is a place where Hive comes to rescue. So that's why even though Hadoop is not a relational language, Hadoop is not a designed for OLTP systems, and Hadoop queries process takes much more. Hive queries takes much more time, and the indexes are not there. But still, Hive is in advance, as I told you, right? So first, what we need to do is that we need to see the structure of your Hive, basically, guys. Once you understand the structure of Hive, then only you will be able to really program these particular things. So that's why today's session and tomorrow's half session is totally dedicated for theory, and based on that one we'll be going further. Okay, so please follow. In how many ways we can execute Pig, guys? In how many ways you can execute pig Latin scripts? In how many ways we can execute pig Latin scripts?
3 ways.
3 ways. What are the 3 ways?
Batch mode.
We can do it with the help of the grunt shell. Grunt shell we can use. Okay. We can try to use with the help of your embedded Java based programs. That is the second thing. And third thing, what is the third one? We can use with the help of your batch mode also as well, right? So these are the 3 modes in which you can have the option of executing your pig scripts. Similarly, you have your user interfaces. These user interfaces are web user interface, and second thing is your Hive command line, and then one is your HD Insight. HD Insight is nothing but your customized script, customized interface that is basically created for the purpose of querying your databases. Ultimately, these 3 things are basically used to query the data that is present in your HDFS or HBase data storage here. So let me show you an interface. How can we have the option of starting your Hive? 1 minute. When you go with this particular Hive, this is the how it is going to start basically. This is how you are seeing, right, Divya? The command interpreter. This is the Hive that we are going to use here.
Yes, Ravi.
This is the Hive that we are going to use here. So that one, what you are seeing here is nothing but the Hive command line is nothing but the interface that we are going to use. Okay. Now, what you are having here is that you are having this particular meta store, which is very, very important. Okay. And then you have your Hive query processing engine, the execution engine, which is going to convert your things into the MapReduce. And ultimately, these MapReduce programs are going to be executed against the data that is present in your HDFS stores. Okay. But one thing what you need to understand here is, see here, one thing that we need to understand is that what is the purpose of this meta store? Can anybody tell me what is the purpose of the data dictionary in Oracle SQL Server or Sybase or MySQL, something of the sort? What is the purpose of your data dictionary? Why should we use this data dictionary? Sorry?
It stores the schema of the tables or whatever data is stored in that.
It stores the schema of the tables, right? It stores the schema of the tables that are present in the database. Okay. Now, what happens is that, let me tell you one thing. This is your database, okay, and obviously what you're going to have is that you're going to have this particular metadata dictionary that this is your what is your dictionary that exists. This is what is your dictionary that exists, and assume that this is the user interface, and here you have your compiler or interpreter that exists. Okay, see here. This is the user interface, okay, and based on this user interface what you're having is that you have this compiler will be there, okay, and here This is your data dictionary. This is your data dictionary. And based on your data dictionary, what you're having is you have your actual data in the database. Actual data in the database that exists here. Okay, so here in the user interface, what I'm doing is that I'm trying to write a command called as create table or select star from EMP. Select star So when I start doing like this, when I specify something like select star from EMP, can anybody tell me? What happens when you specify select star from EMP? First thing what I need to do is that don't I need to think whether this particular EMP table is existing in this one? If the EMP is existing, then only my compiler will be able to compile that one into the execution plan in order to retrieve the actual data from the database, right? So that's why even before the SQL statement is compiled into the execution plan, and then if it is hitting your database, what happens is that this particular compiler has to check in your data dictionary whether that object is present or not. Okay, if that particular object is present, then only it will go ahead and then start hitting your data dictionary, right? It is going to hit your data dictionary. And where is this data dictionary going to reside? Is it not going to reside in the same database, guys? It is going to reside in the same database, right? The structure of the tables that are present also will be residing in the same database only. And what are the other names for your data dictionary? It can also be treated as a catalog, or else it can also be treated as a schema, right? Murli?
Yeah, right.
It can be treated as a catalog, or else it can be treated as a schema also as well. So that's how your data dictionary is going to play a critical role. So in a nutshell, what we can say is that even before your SQL statement is going to hit the actual data that is present in the database, it should hit the data dictionary to understand the semantics of that particular database object, whether it is present or not, and whether you have these authorizations to access that database or not. All that information should come from your data dictionary only. Okay, now tell me, is Hadoop, is this a HDFS a file system or a relational database? Divya.
File system.
So in what form your data is going to be stored? In the files or tables?
Files.
It is going to be stored only in the form of files. Okay. And how do you access those particular files from the HDFS? What is the process of accessing the files from HDFS? Suppose if a client would like to access a file that is present in HDFS, what is the first thing that he need to do? Tell me.
We need to place a request to the and check if file is present in the file system or not using the job tracker.
Where should we place the request?
From the request image.
We should place the request to the name node, right? The name node is the place where all your metadata information is present, and based on the name node, what metadata node, what data nodes it is going to give, then the client is going to access those particular data nodes for the purpose of getting the data. That's how it happens, right? Basically.
Yes, sir.
Okay. So here also, what happens is HDFS is a file system where your data is ultimately present. Okay. But one thing what we need to do is that, I have told that Hive is going to use the query language. What is that query language? I'm going to use the create statement. I'm going to use the drop statement, order statement, okay, insert statement, update statement. These are all the things that I'm going to use. Okay, when I'm using them, on what type of metadata structures it will work? Will it work on the table structures, or else it will work on the file structures?
Table structures.
It will work on the table structures. Okay, but now the question is that can we store those table structures as tables within HDFS?
No, we have to
Can
convert
we?
them to file
Yeah,
structure.
we cannot. We cannot convert those. Sorry, we cannot store the table structures as table structures within HDFS. They have to be ultimately converted into the file structures. Okay, while storing the data in HDFS, right? While storing the data in HDFS, but I need to have that particular table structure, right? I need to have that particular table structure that should be created. Okay, so for the purpose of maintaining such type of table structure, what happens is there is one type of store that is going to be present, and that particular store is nothing but the meta store, which is very, very important. Which is very, very important. Meta store is nothing but the data dictionary, okay, or else it is nothing but the database. Okay, so whatever the structures of the tables that are being created through Hive, okay, those particular structural schemas are going to be stored within this particular relational database, and actual data of those particular tables are expected to be stored within this particular HDFS, and metastore also what it will do is that it will try to identify, okay, in which name node that particular tables are, in which data node those particular data of those particular tables are present. All that entire directory of that particular data is also going to be stored within this meta store, which is very, very important. So that's why so when you create the table structure, where the table structure is going to be stored, the table structure is going to be created in this particular meta store. But when you start inserting the data into that particular table, where the actual data is going to be stored, the actual data is going to be stored within your HDFS files. The actual data is going to be stored within your HDFS files. So Shashank, can you please repeat what I'm talking about?
Yes, Ravi. So the actual data is actually stored in HDFS, but whatever we try to query through the Hive command line by creating tables and all, that schema is stored in the metastore as a metastore database or something like that, a repository.
Yeah, it has to be stored in this particular metadata database like this. Okay, so then come to this conclusion here. User interface. What is the user interface? The interaction between user and HDFS. Again, I'm telling you, the interaction is happening between the user and the HDFS only. The user interfaces that Hive supports are the Hive Web UI, which is we are not really concerned. We are not also not talking about your HD Insight, but we are only talking about your Hive command line. And how to get into that command line? The moment once you enter into the terminal of Linux operating system, simply specify Hive. That itself is going to take care of your Hive command here. And what is this metastore here? I told you, right? Hive chooses a respective database servers, be it MySQL. There is one more thing called as debris size. 1 minute. Let me check. One minute. So, database. DB, 1 minute. It is something like DB. Platforms. Form names. Database platform names. Derby. This is the platform. Apache Derby. Generally, while installing Hive, okay, what automatically happens is that it need to have the JDBC connector or the ODBC connector to connect to a particular database. Okay, since we are always working on the Apache platforms, okay, Apache has come up with its own proprietary database. That own proprietary database is what is called as the Derby, which is also treated as Apache Hive Metastore. Okay, you can also have the option of using Oracle MySQL, or else you can also have the option of using SQL Server. Also, you can use, but here in the installation, what you're having here, it has been used with Apache Derby basically. That can be used, or else in your Hadoop ecosystem, what you are using, you also have your MySQL that is being configured. Anything that can be used, but basically it should always be a relational database. You need to remember this particular name, that is Apache Derby is something that you need to really remember to proceed further. Okay, that is the metastore, which is used to store the structures of the tables that you are going to create. Okay, and what I have told you here, HDFS and HBase, Hadoop distributed file system, are the data storing techniques to store the data within the file system. So whatever intermediate platforms what you're having here, I really don't bother, but ultimately your data is expected to be stored within your Hadoop distributed file system only, or else in the form of your HBase. HBase is something that will be taking up once we complete your Hive. So that's why there are two storage techniques. One is HDFS and second thing is HBase. Okay, and process engine I have told you, right? It is nothing but HQL is similar to SQL for querying on schema, info, and the metastore. It is one of the replacement of the traditional approach for MapReduce programs. Instead of writing the MapReduce programs in Java, we can write a query for MapReduce job and process it. Okay, and execution engine, what it is doing here, it is going to convert your execution. See here, execution engine process your query and generates the result as a schema of your MapReduce results. It uses the flavor of MapReduce. Okay, so guys, what is happening here? I have told you. What I have told you here, I'm going to use your user interface as what I have told you here. I'm going to use your user interface, that is Hive interface, for the purpose of writing your SQL queries. I really don't call them as SQL queries, but I'll be calling them as HQL queries, right? I'll be calling them as HQL queries. High query language queries I'll be writing. Okay, once I create this particular HiveQL, then automatically what happens is it is expected to be submitted to this particular Hive query processing engine. What this Hive query processing engine is going to do here? It is one of the replacement of the traditional approach to MapReduce programs. What it is that it is nothing but similar to SQL for querying the schema information in the metastore. Okay, but when submitted to the execution engine, Hive query language submits this one to the execution. This is just like a compiler. It checks with your metastore whether your database objects are present or not, whether you have the correct authorizations to access that particular information. All that information is going to be fetched with your HiveQL processing engine. Once it submits, then what it is going to happen here? It is going to submit to your execution engine, okay, for the purpose of converting your plan into your MapReduce programs, so that every MapReduce program is executed against the HDFS file for the purpose of retrieving the results and then give these results back to your web interface. That is what is going to happen here. See here, the conjunction part of your Hive query process engine and the MapReduce is a Hive execution engine. Execution engine process the query and generates the results as the MapReduce results. It is a flavor of your MapReduce program, right? That's why it is going to happen here. So this is how it is going to happen here. You are going to have the name node, you are going to have the data node, the task tracker, the job tracker, and this is here. This is what is your Hive. So you have your metastore here as well as you are having your data node here. So can you tell me, Shashank, now what is stored in the metastore and what is happening in the data node? What is stored in the metastore and what is happening in the data node?
So basically in the metastore, it stores the metadata of the tables we create through the Hive interface, Hive UI. And after you, whenever you do a query or create table, that interacts with the execution engine, and in turn execution engine interacts with the job tracker or one of the components of the map reduce. Where it grabs the metadata from metadata of that HDFS file system. Here it is tables and data stored in tables. Now it is file system, and it pulls the data from the data nodes in the HDFS.
It pulls the data from the data node in the HDFS and ultimately gives you the result set in the form of your interface only. So the step 10, what you are seeing here, sends the results. The driver sends the result to the Hive interface. This is what is your step 10. Okay, and what is one coming up here? The one is coming up is the Hive interface sends the command line as sends a query to execute, right? Then it gets the plan, gets the metadata. So gets the metadata means the compiler sends the metadata request to the metastore, any database basically, and then it gets the metadata. Then it will create the plan, and then this is the place where your execution plan is going to come. So what is happening here? The process of your execution job is a map reduce job. The execution engine sends the job to the job tracker, which is a name node, and it assigns to the SAM tracker into the data node. Ultimately, what is happening here? Is it not the map reduce program which is getting ultimately processed, Divya? Ultimately, it is going to be the map reduce program only that is going to be processed, right?
Yes, Ravi.
So the execution engine retrieves the results from the data nodes. And when it is retrieving the results from the data nodes, is it not the actual data that is being retrieved? It is only the actual data that is being retrieved, and then it sends those results back to your results, and then the driver sends the result to this particular Hive interface basically. That's how it is going to happen. This is what is Hive. Okay, so what we do is that we have written some of the programs, the weather example, the count example, or what are the other things here? The ranking example, the user tweets example, whatever all the examples that you are written in MapReduce, the same examples has been mimicked using Pig, right? So again, within whatever all the things that what we do, how to join, it is something like a SQL only, guys. It is only a SQL. How to create the table and how to insert the data into the table, and how to retrieve the data, and then how to join, how to filter, how to sort, how to aggregate, and what are all the results that we want to do, and how is the interaction that is happening between your I told, right? How is the interaction that is happening between your Hive to this particular MapReduce is something that we are going to see within this Hive starting tomorrow. That's how it's going to happen. We'll be discussing about the data types. We'll be discussing about how to create the database. All those things we'll be discussing, and this is all common notations once we are doing. Then what we do is that we go with the HBase, which is nothing but a NoSQL. NoSQL means not only SQL, which is nothing but a columnar database that we'll be using in order to discuss this alternative here. What is, if you have your HDFS, see here. If you have your HDFS, you also have your HBase, which is nothing but a NoSQL database that we are going to see as soon as your Hive is completed. So this, once it is completed, we have almost completed what is your ecosystem here. Then we'll come to this particular Scoop, Flume, and then Zookeeper, and then Uji. What are all these things we'll be seeing, and then we'll be going ahead. Okay. Any questions before we conclude today?
Ravi, we studied about Pig, right? Does Pig have schema? I mean, whatever the data we
Pig does not have any schema. Pig doesn't maintain any schema basically. Pig doesn't maintain any schema. Pig maintains the data only within the temporary stateless relations, and that stateless relation is expected to expire as soon as your session is completed, Shashank. Okay, but if you want to have that particular persistent state, instead of using that load command, use the store command also as well to load the data into your persistent state of HDFS.
Okay. Yeah.
Okay. Tomorrow we will go ahead with respect to your Hive queries and the data types and what are all the comments, what are there, we'll start seeing them eventually. Okay. Thanks guys. Any questions you're having, please let me know, else good night.
Thanks, Ravi.
Good night, Ravi.
Kamran is there today?
Yes, I am here.
Oh, great man. See you sir tomorrow.